This is the AquaPark, St. Charles Pool Complex, located at St. Charles College in Pietermaritzburg. Even though this project was nominated by SAISC Steel, there's a whole lot of stakeholders involved that made this project what it is, and we're all involved in how it came about with all the different elements. Just to go through it, obviously, like I mentioned, as we finish off, we will fill out some of the missing details, but the architects were Greg Bella Architects involved. And just to run through, and Mark, I'm not sure if you could speak on behalf of the architects in terms of, what was the brief, and obviously we'll jump into the nitty-gritty in terms of how steel played a role beyond the aesthetics and all the functional benefits.
Right, I could probably help out Mark's on the architectural, because I was more involved until he got involved there, Axel.
Yes, perfect, thank you.
All right, so the architectural brief was obviously to provide a covering and an aquatic park for a 100-meter Merthyr pool, which is quite interesting. It's a precast steel pool which was coming from Italy, which actually held the Japanese world swimming galas. So what happens is it actually gets dismantled and re-put up here in South Africa by the Italian pool called Merthyr. So that was our brief, and that's how it all started. And then obviously the steel was obviously decided because of the spans of which we had to get over the pool with no supports in the middle for obvious reasons. Right.
Perfect. And I think just to add on top of that, I think that's where the use of the cellular beams come through, where, in the past, we've supplied curved cellular beams to numerous projects where creating column-free spans was required. We did a swimming pool in the past as well for the Namibian Army. That one was about 38-meter free span, and it gives you that flexibility as opposed to other design elements where one could have gone with, for example, like a curved lattice, trusses. But in this instance, they went with curved cellular beams. Just to give you a quick project overview, completion date was the 1st of December last year. Total cost of the project was around 120 million, where it falls under the sector of infrastructure with regards to the various categories we're going to have at the Steel Awards. Just jumping into this, it obviously showcases a signature curved roof utilizing the cellular beams that we provide in the market, supplied and fabricated with Cousin Steel International. The design required long, uninterrupted spans, as mentioned by David, through 13 and 9-meter curved cellular members, which we obviously produced before it was spliced and put together, giving a 42 to 48-meter sweeping rafter span, and an internal radius of about 47.1 meters. And then this obviously then created the column-free environment that you then see, which is quite striking from an architectural point of view. And obviously the curve being quite a significant feature of the particular structure. And then obviously as we get to the roofing section a bit later, you'll see we also then used our Novatexi for the concealed fixing, which Dave later on will jump into more details. Just in terms of the motivation we had put in terms of this particular structure, and just the steel was obviously the use of the curved elements that created that long span. Because you could imagine for an aquatic environment, you wouldn't want to have any a lot of obstructions within, so that if you're having spectators, everyone there watching the various sports that can be played there, you would want a space that is clear and open, and obviously delivering a world-class aquatic center designed by the team, to ensure that when the athletes are there, the community and everything involved, it does give that aesthetic appeal. Just as an overview from a structural steelwork point of view, and Mark, I don't know if you want to step in here just to jump in and give a little bit more detail.
Yeah, excellent. Thank you, man. Yeah, I just wanted to, obviously, dealing with Dave Varga, we've dealt quite a bit with him. Gordon and him have done many jobs together, and it always helps having the engineer on your side when we're designing, or when they've designed stuff like this, because obviously rigging purposes on site, it always helps, or we quite enjoy doing the modular lifts, which obviously lent itself perfectly to do the modular lift. We did obviously originally anticipate lifting from inside, but obviously because of, I can't actually remember what it was exactly, but there was a reason that we weren't able to work inside, and I think it may have been the footings or the foundations of the swimming pool. We ended up using the bigger crane from the outside, and as per the time-lapse video, you could see those modules going in, and I think we lifted that in 6 days. It was 4 modules, and it just lent itself to a quicker erection process, and obviously inspecting the steel before it went into the air, which obviously helps everybody a great deal.
Perfect. Thank you for that. We're now going over into the metal cladding our portion. Later on, I do have some slides, Dave, where you can then go in and speak in greater detail. But you can just give a brief intro before we get to the point where I'll show you the different images you can speak to.
Yeah, thank you, Axel. As far as the roof sheeting goes, we used the sky forming process, and that lends itself to a lot of advantages for this construction team. Having the mill on site and lifting it up with a crane and hanging it at eaves height, and then rolling continuous sheets onto the roof. One of the big advantages are the space that you use while you actually rolling the roof sheet. Secondly, it's continuous with no lapping on it. And then the condition of the product when it comes out the mill is perfect. There's no scratches on it, no denting and anything like that. And yes, because of the radii on this building, we can naturally spring the Novotexi, and it's worked out well and it looks stunning.
Perfect. Thank you, Dave. With regards to the structural framing, I've added some images, and I'm not sure if any of you guys want to speak through it. That obviously, essentially giving a brief description of the structural framing, and in terms of how this project illustrates the benefits of steel as a material, load pass bracing systems, overall stability. David, I think you may be best placed to give some insight on this. I'll just go through some images if there's anything in particular you might want to touch on.
Yeah, just an overview. Obviously, you said it's a 41-meter span and 47-meter radius, which obviously lent itself beautifully to tying in to the, as you can see, the concrete ring beam. We also introduced a tie beam at the 1/3 points, which you can just see. The reason for that was to obviously help the deflections and deformation of the actual rafter during the erection process. It also doubled up as a stability bracing for that mezzanine little walkway that you've got there, which you can see the guy standing on in the front. Those curved rafters you can see at the end were connected to the concrete beam just by a little short stub columns. and the ring beam was obviously there to pick up the horizontal forces. Because obviously a beam like this has quite severe horizontal forces that it's acting on. The load path was effectively going into that concrete ring beam, and our bracing system, just to talk you through that, was a series of 127 mil tubular sections, which you can see in the forefront here, and then along with the longitudinal bracing, which was that acted as a tie beam, which you can see the hangers there. The overall strategy that we can discuss was really that we had to have that heavily reinforced beam around it to stop those legs spreading. That was probably the biggest hassle we had, because we started with structural steel columns, but it just ended up so heavy that we introduced the concrete, which in the long run worked out very nicely for them to actually be able to erect and place it on top of those beams. I think that's about it. Yeah.
Now this is just further images just to what David was talking about, and it's actually quite interesting, David, that you mentioned the concrete ring beams, because I've also found when assisting architects and engineers in industry with specifying the curved cell beams, and especially when the profiles start getting quite large in terms of the spans, I'm always worried about what profile are they going to use for the columns, because you're then thinking in terms of the load that they're going to carry. So seeing that you went the concrete route here, which ended up being quite conducive for the structure, is actually something that I've also learned a bit, where I know, okay, in future when also assisting and specifying, that's also an alternative route the architects and engineers can look at in getting the structure to work, especially when the client is insistent that they want their structure to have a structural curved element.
Yes.
I'm just going to jump into the roofing in a bit more detail. Dave, here you can go into a bit more detail with regards to the sky forming with the Novatex. Here I have a few images that detail what the guys are doing and how it's coming about, so you can jump in.
Okay, one of the other factors with Novatex and rolling curved sheets is we roll one of the interlocking joints in what we call an open format, so you can basically engage the sheet on a horizontal plane. The sheets are then put together and crimped to get the cover width right, and then after that it gets seamed up. One of the other factors is always expansion and contraction, and based on our experience with Pick and Pay, where we had 280 meter long sheets, we're very happy with the movement, what we call the slip joint between the male and the female and the actual fixing bracket, to be confident enough that this sheet can move freely based on the radius, and you don't have any unclipping happening or any disengagement. But there you can see the mill hanging at the eaves level. We've actually got to the point that on some contracts, sky forming, we've been able to roll about, I think the record that we held is 3,800 square meters a day. So it's an extremely efficient process as well. So yes, it came out very nice.
Thank you, Dave.
I think for the team, if I can add in there, Axel,
yes,
the desperation and the program was very, very tight because of the pool that was arriving on set date. And so Mark and Dave had to get this thing covered because the pool guys would refuse to let anybody work over the top of the pool after the thing had been installed. So it was a rush to meet those times. So we really appreciated that time that the guys did to get that in on time.
Thank you for that. I do not know if you want to jump in a bit more on any challenges or anything experienced from a fabrication stage point of view. I know post this interview, I'll see if I could try get more images from Mark and Adam in terms of adding to this particular stage. But from a fabrication point of view, I know I can add a bit in terms of with manufacturing the curved cellular beams. We did not necessarily encounter any big issues in achieving the curved radius that was designed and specified by the engineers. We were able to curve to what was required. I do recall when delivering to Cousins that there weren't necessarily any major issues with any of the radiuses being significantly out. I think we were able to achieve that radius right throughout across the majority of the beams. Sometimes I always get a bit worried throughout transportation and with the self weight of the beams, if that affects the radii in any way. But what we found with the way that we produce the curves and build it into the beams, because essentially the way that we do it is, we'd work from two different beams. And as we pull the beams apart, because you can imagine if you're splitting a beam in half after profiling, a lot of the inherent stresses release. So it's actually quite easy to pull the material and then re-weld it in accordance with the radius. But obviously, by using two different beams, ensuring that the arrangement of how it's been profiled, all the holes and the diameters of the holes and then the spacing all line up so that the web posts aren't out in any way. But I think from that end, I don't know if there were any how everything went from a fabrication point of view. I don't know if you want to jump into any more details there.
I don't know, Gordon, from your side, is there anything you want to say on that?
Well, basically they were all built in a jig. There was a jig set out on the floor, so we had to bend them back into the jig before the absolute finished welding. And it worked out very nice. I mean, curved beams, cellular beams always work out very nice.
Perfect. Thank you for that. I know we did go through some of the erection and construction in our prior discussions. Lizo, you will see a nice time-lapse video that will be put up in the Dropbox link with all the other photos that will obviously highlight and showcase that. But these are just some other images throughout the construction and installation process that go in and detail what the team obviously went through. I do not know if there's any specific challenges and solutions we want to touch on, but I do know earlier on when we started this, David did go through some of those challenges and the solutions that came about in how we got it to work. Essentially, Lizo, I'll add a quick write-up here on the benefits of the steel overall. But a lot of it was mentioned throughout this interview, because I do know we are pressed for time. And I do not know if there's anything anyone wants to touch on with regards to anything related to quality assurance, sustainability, or efficiency.
Yeah, I think from just on the challenge side, as always, wind and rain is obviously a big one. I know during the sheeting process, we had a couple of days downtime. Obviously, couldn't do anything. But obviously, as Dave Reed mentioned earlier, obviously having that scar forming and having the crane there obviously helps, because yes, you lose a day, but the next day we catch up if the weather's good because we started early or whatever it may be. And then in terms of the erection of the steel, we also had a slight challenge in the beginning, but it was a simple phone call to Dave Varga, and it was purely, I think, because we'd obviously were going to lift from inside the swimming pool, then we went outside, and then we obviously didn't have the slings in the correct position. There was talk about adding some extra pipes in there, but eventually it wasn't necessary. We actually managed to get away just by adding an extra couple of slings in there, and obviously that's in that time-lapse video how that all went down.
Perfect. Thank you so much.
Yeah,
for
I
that.
think from an engineering point of view, we were very happy. I didn't think we'd need to undo that tie beam, but obviously that helped, which was quite interesting, which I didn't think would happen, was it actually closed on itself as opposed to spreading, Axel.
Nice.
When they lifted it with the lifting beam, it actually closed in. And I got the dreaded phone call, oh, the holding down bolts must be in the wrong place. And then we realized once we released the tie beam, then it actually spread itself back out, and they were able to erect it and then re-bolt the tie beam together. So, learning curve, we're never too old to learn, eh, Mark?
Yeah, I appreciate you taking the call.
And as they always say, that sometimes you always learn something new every day, and then you take what you learn and then apply it on the next one. But I think Lido, it's also just also an indication when you have project teams where there's alignment throughout, where you're having engineers, fabricators, everyone aligned in obviously understanding. I mean, there's times where, from a fabricator's point of view, or even from an engineer's point of view, where there are projects where teams and stakeholders may not be aligned in terms of also understanding the technicalities of things. And when you have one role player, for example, maybe not understanding or being a bit difficult, it just makes sorting out challenges, problems, and getting to solutions much more difficult. So in what we've showcased, today, you can clearly see that when there were challenges faced, how there was the collaboration between all the different stakeholders, and where, for example, a day may have been lost, you catch up in trying to meet the program.
100%.
And yes, and just I think, look, and just finishing off, and just what we're proud of. I know, for me, obviously being the industry expert on cellular beam, it's always nice, seeing the applications. I personally quite love doing the curved applications that we have on cellular beams, because it just goes in and showcases the the flexibility of steel, of where we can use it. As an engineer, it's always quite funny where they always say that we don't have an architectural touch to what we do, but when you see how some of the structures come out, especially on this one, there's also some nice architectural elements in having a nice curved structure. And also, as much as we are always steel positive, it's also nice seeing how the marriage between two different construction materials coming together for the benefit. So even though here we do have reinforced concrete being used, the benefit of it in making this particular steel structure come about. So there's elements like that make me feel proud in terms of that. And also it's also nice when you're working with fabricators and engineers, where everyone is aligned, everyone understands, because everything runs smoothly. So with us supplying steel to Cousin Steel, and understanding, okay, this is what they need, this is the program they need to work on, and ensuring that our manufacturing production doesn't hamper them in any way, so that they also able to go in and deliver on the project to the client. So that's something that I'm proud of, and just seeing the technical ability of the team shine through with this. And then rest of the team, I'm not sure if you guys can also just add on other elements that you're just also proud of on this project.
I think, Axel, from our side, the end user is absolutely ecstatic with what has come about, and everyone that's used it so far. I mean, they've had national galas, they've had national water polo tournaments, and it's actually livening up Pietermaritzburg in the swimming industry. we're going to be actually ending up having international swimmers and holding national galas and everything under this one roof, which was really taken a lot of the galas and that away from King's Pool in Durban, which is unfortunately in disrepair. So it actually arrived at just the right time, fortunately. That's all from me.
Anyone else want to add on?
Yeah, Axel, if I can just add on there, with the sky forming process and this specific project, I mean, we've been going probably about 5 years with the process. When we started it off in South Africa, I think there was a lot of doubt of the efficiency and the quality that you get out of this process. But I think what Mark and David alluded to, it's definitely become extremely popular in the construction industry. It's efficient. It limits any damages on the roof while you supplying a supreme product. And I'm very proud to be able to look at all these projects that have been done with this method of supply. And I'm also stoked about how that building came out.
Yeah, I think from Cousin Steel's side, I mean, we always aim to hit those dates that we're given that are unrealistic at most times. And I really think on this one, we kind of nailed it, as we actually hit this one within the program dates. And I don't think too many people were unhappy. I think on the sheeting, we were slightly late, but that was purely based on weather, and it had nothing to do with the production on site or people not trying to get it done. So I was very impressed in terms of hitting the actual dates that we needed to. We did a bloody good job on that, and that was all around, from main contractor to sheeting to steel. Everybody did their share of the job to get it done, and the pool went in on the 1st of September, and everybody was pretty happy as far as I'm aware.
No, thank you, guys. I think we've definitely showcased this particular project.